Okay guys, we're going to talk about law of sines today. This is another way that we can solve for missing parts of an oblique triangle, so a non-right triangle. Notice no right angles anywhere here. All these angles, none of them are right angles. So we can use law of cosines, which hopefully you remember from last try or the try before, depending on when you had this. Or we can use law of sines. Law of sines is actually even easier, so it's a good thing we did cosines together. So I'm gonna just write out the rule for you. So basically we have sine of A, and that's gonna be your angle measurement. So notice all the angles are capital letters here, and then we're gonna divide by the side that is opposite that. So angles are gonna be paired with the side that is opposite that angle. So we're gonna put this over side A. And that's gonna be equal to or equivalent in value to sine B, that angle, divided by its opposite side B, or it's also equal to sine C divided by side C. Again, capital letters for the angles and lowercase letters for the sides. So we're gonna work through a couple examples together and see how this works. So if we're looking to solve for side AB right here, I'm going to call that side small c because again it corresponds to this angle C over here, opposite sides, and that matters. I need to line those up. So I'm going to do sine of 53 divided by C. I don't know what that is yet. And then I'm going to use the other pair where I do know the information, and I'm going to say that's going to be equal to sine of 44, again angles with the sine, divided by the side, which measures 7 units. Okay, so now we have a proportion set up. We know these are equivalent fractions basically, and we need to solve for a missing side. So we're gonna cross multiply. In other words, we're multiplying by 7 to get it out from the denominator. We're multiplying by C to get it from the denominator. So what we essentially do is cross multiply. So then we're gonna get 7 times the sine of 53 is going to be equal to C times the sine of 44. Again, cross multiplication is just inverse operations. We're just getting rid of the fractions here. Okay, so now we can calculate this in our calculator. So you're gonna do 7 times the sine of 53. Make sure that your calculator is in degrees. And you're gonna get approximately 5.59 something, something, something. And then I need to divide by the sine of 44. So we're going to divide that 5.59 by the sine of 44. And then we get 8.05 about. So that's an approximate because I have to round for this. So that's what C, our side, our missing side, is going to equal. It's going to be about 8.05. And then you can ask yourself if that makes sense. So we know that this angle 44 is opposite a side that's 77. This angle right here, 53, is slightly larger, so the angle that's the side that's opposite it should also be slightly larger, which it is, 8.05. So that answer makes sense. We're calling it good. Moving on to the next example. Okay, now I'm trying to solve for side AB again, and again, we're gonna call that C because it's opposite angle C. So we're gonna set this up, sine of 63 divided by side C is equal to the sine of angle A, because that's what I have for this missing piece here, but I don't know what angle A is yet. But I know that all triangles, all the angles for triangles, so the angles in triangles, add up to 180. And that's called the Triangle Sum Theorem. So all angles in a triangle add up to 180. So we can solve for that missing angle A there simply by subtracting from 180. So we're going to take 180 minus 101 minus 63. And that's going to give us our missing angle here, which is 16 degrees. So this angle A is going to be 16 degrees. So I'm going to plug that in there. Let me give you a different color here. So this angle measurement here is 16 degrees, again, by Triangle Sum Theorem. So that's what I'm going to plug in here. It's opposite this side over here, 9. So that's what's going to go in the denominator of my fraction. So now we're going to cross multiply, and we are going to solve for side C again. So when we do this, we're going to get 9 times the sine of 63 is going to be equal to C times the sine of 16. Plug that into your calculator. We're going to divide by the sine of 16, divide by the sine of 16, and we get that C is about 29.1 after rounding units. Again, this is a side measure. So let's check that again and see if our answer makes sense. Side C is opposite this 63 degrees over here, so it should definitely be significantly larger than the side we know, which is 9 opposite 16 degrees. So 29.1 seems to make sense to me. So we're going to call that good. Okay, now we have a word problem. This law of sines is actually used in real life all the time. So we're going to look at a word problem that talks about a real life situation where you might need to solve for missing pieces and evaluate a situation. So what we know is this team is traveling and they're going to, obviously this is pre-coronavirus. So we're traveling from Philadelphia, 138 miles to Euclid. And then from Euclid, we're going to travel to Pythagoras. And we're gonna then travel back home 97 miles to get back to Philadelphia. But our bus can only go 300 miles on the gas that we have. So we need to figure out if we have enough gas to make that whole round trip or if we're gonna have to stop for gas on the way. You know, planning purposes so I can tell your parents when to pick you up. Okay, so let's draw a picture first because I need to give myself a visual representation of what's going on. I'm gonna call Philadelphia P. So that's our starting point. We then travel 138 miles to Euclid. I'm going to call that E. And then we travel some distance we don't know. We have no idea what this is going to be, but we're going to go to Pythagoras. I'm just going to call this Y since we already have a P. I don't know what that distance is. I'm going to call it baby P since it's opposite the P angle over there. And then we know that this angle right here that connects Philadelphia to the other two cities is a 28-degree angle. So now we can solve for the missing sides and decide if we have enough gas to get there. So, and then we also know that this is a 97-mile trip from Pythagoras to Philadelphia. Okay, so what we have right now is a side angle side situation. We don't have any opposite angle and side measures, so we're gonna have to use law of cosines, which is from the first trimester or the first half of Math 3. So that equation, hopefully you recall, is a squared equals b squared plus c squared minus 2 times bc times the cosine of angle A. Notice that side A and angle A are on opposite sides of the equation, and that's the key there. You can use this to solve for any missing side or angle that you wish. You just need to make sure that the side you use is opposite the angle you use. So in this case, we want this to be 28 degrees because the side that we're solving for is this P over here. So we're gonna, right here. So we're gonna call it P squared equals our two length measures we know are sides, 97 squared, plus 138 squared, or minus 2 times those two values again, 97 and 138, times the cosine of angle A, which is 28 degrees. Again, make sure that your calculator is in degrees, and then you can basically just enter this as one long problem into your graphing calculator. You can do it by pieces as well, but no, you will get rounding errors if all of these values are not being stored in your calculator, which if you're using your phone because we're at home, then you're just gonna have slightly different values than I do because of rounding errors. So we end up getting P squared equals 4,814.73 about. Again, I'm rounding here. So then when I take the square root of both sides, I get that P is about 69.4 miles long. So that gives me my missing side measurement. So now I need to add the three sides together and see if I can travel my 300 miles or if I need to go and get gas. So I'm going to take 138 plus 97 plus 69.4, again, about, and that's gonna give me about 304.4 in this case, which is too big. I need to stop for gas. So we're gonna stop for gas because I can only go 300 miles and 304 is just a little bit too much. Okay, then the last question I need to answer is they want me to solve for this angle E here because that'll show you one more thing. So we're going to solve for angle E. Now that I have an opposite pair, I have 28 and I know that side P is about 69.4, now I can use law of sines. So that makes my life a little easier because it's a little bit more straightforward than law of cosines. So I'm going to do sine of 28 divided by that side we just solved for, 69.4. I'm going to set that equal to the sine of E, what I want to solve for, divided by 97, sorry. Lost track here, divided by 97, which is the side opposite angle E. So then we're going to cross multiply, and we are going to solve for that angle E there. So we're going to take sine of 28 and multiply by 97, and that will give you about, again, all of these are about, we're going to get, so when we cross multiply here, we get 45.5, etc., is about equal to 69.4 times sine of E. Now I'm going to divide by 69.4 to isolate that sine of E piece. So divide by 69.4, divide by 69.4, and we get 0.656, blah, 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 is about equal to the sine of E. Now I need to do inverse trig. So to get this angle all by itself, we use that sine -1. Again, we're going to use inverse trig to solve for angles. In this case, we're solving for an angle. So we're going to take we're going to take sine -1 of that 0.656, blah, 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 and that's going to give me that angle measurement. So when we do sine -1 of your answer, if you're using a graphing calculator, plug in the actual answer so you avoid rounding errors. If you're using your phone, just make it work, it's okay. And we're gonna get that angle E is about 41 degrees. Again, that's how we could solve for an angle given law of sines, which is what we're gonna do next as well in our last example. So last but not least, we're gonna do this example here. We're solving for angle C right here. And so we're going to set that up using C, capital C, as our missing piece. So we're going to do sine of C divided by 6, because that's the side measure opposite that angle there, is going to be equal to, what's the other pair that I have opposites for? This A pair here. So we're going to do sine of 103 divided by 26. Again, setting up for the pairs that you have given the information that you have. Okay, so we cross multiply, we get 26 times the sine of C is equal to 6 times the sine of 103. We're going to plug that into our calculators, divide by 26, divide by 26. We get that sine C is about equal to 0.225 something, something, something. Now we're gonna do arc sine or inverse sine of that value, 0.225 something, something, something. And that will give us our angle measurement. So in this case, we get C is about 13 degrees. Again, at the end of each of these, ask yourself if your answer makes sense given the information you have, and you go from there. Hope that makes sense.